Let's say you have some functions lying around. One way you can get some new functions is by combining those old functions in various different ways that we're going to be talking about in this section. So you can take two functions and add them, or subtract them, or multiply them, or divide them, and get a new function. That is the sum, or the difference, or the product, or the quotient of those old functions. So the sum of two functions, f plus g of x, is what you would get if you just took any number for x and evaluated f of x and g of x separately, and then added the results together. And of course, to be able to do that, you have to be able to evaluate f of x and g of x individually. So the domain of f plus g is made up of everything that you couldn't put into both f and g individually. Often, that's going to be all real numbers. But if there's anything that doesn't work in either f or g separately, then you're not going to be allowed to plug it into f plus g. I can say similar things about f minus g, and f times g, and f divided by g, and then also with division, we're not allowed to divide by 0. So for the domain of the quotient function, we have to exclude any x that would make the denominator come out 0. So if you're looking at f over g, g of x cannot equal 0. So x, what we plug in, can't be anything that makes g of x equal 0. So now let's work through some examples. Here we got two functions. F of x is 3x plus 5. In other words, it's the function that takes whatever you give it and gives you 3 times that number plus 5 as the output. And g of x is 4x minus 1. It takes whatever you give it and gives you 4 times that minus 1. And there's nothing special about these functions. I just picked them for an example. So what is the function you get when you add these together? The new function f plus g of x. Well, if we add together 3x plus 5 plus 4x minus 1, after simplifying that by combining like terms, we get 7x plus 4. So 7x plus 4 is what you end up with if you take any number for x and evaluate f of x and g of x and then add those two numbers together. F minus g of x would be if we take f, which is 3x plus 5, minus g, which is 4x minus 1. Now be careful, don't forget we are subtracting that whole thing. Don't forget to subtract the minus 1 part. A common mistake I see people make is they go, okay, it's minus 4x and it's minus 1. No, it's minus 4x minus 1, which means it's minus 4x and it's minus 1. And when you subtract a negative, that's the same as adding a positive. So after you combine like terms, this simplifies to negative x plus 6. 3x minus 4x would be negative 1x, or just negative x, and 5 minus negative 1 would be 6. So the result is negative x plus 6, or you could write it as 6 minus x. What about f times g of x? When you multiply these two functions together, 3x plus 5 times 4x minus 1, we can multiply that with the FOIL method. First, we get 3x times 4x is 12x squared. Outside, we get minus 3x. Inside, we get plus 20x, so that combines to plus 17x. And last, we get minus 5. So 12x squared plus 17x minus 5. And so far, all of these functions work for any x. The domain is just all real numbers. That's the domain for f. That's the domain for g. So that's the domain for f plus g, and f minus g, and f times g. And what about f divided by g? Well, that would be f, which is 3x plus 5, over or divided by g, which is 4x minus 1. And there's not really anything we can do to simplify that. We have to just leave it like that. And notice that the denominator, 4x minus 1, we don't want that to be 0, which means x cannot equal 1/4, because that would be what would make the denominator be equal to 0. So the domain for the quotient function is all real numbers except 1/4. Let's look at some more examples. In these examples, we've got new functions for f and g. F is now x squared minus 3x plus 2, and g is now 2x minus 4. Find f plus g of 5. Now there's two ways we can do this. One way is, since we just want this specific number, we don't care about f plus g in general, we just care about what it gives us when x is 5. So we can separately evaluate f of 5 and g of 5, and then add those two numbers together. So f of 5 would be, if we take f and put 5 in for x, we get 5 squared, which is 25, minus 3 times 5, which is 15, plus 2. So 25 minus 15 is 10, plus 2 is 12. And then g of 5, when we put 5 into g, we get 2 times 5, which is 10, minus 4, which is 6. So now for f plus g of 5, we just add those two numbers together. 12 plus 6 is 18. Now we could have found the general formula for the sum f plus g of x, and then plug 5 in for x. Let's see what that would have looked like. So if we just, first of all, find the general formula that we get for f plus g of x. We take f of x and g of x and add them together. Combining like terms gives us x squared minus x minus 2. And then we put 5 in for x. So f plus g of 5 would be 5 squared minus 5 minus 2. That's 25 minus 5, which is 20, minus 2, which is 18. So we get the same thing either way. Either approach works. Let's try f minus g of negative 3. So again, we could, if we just want the number, we could calculate f of negative 3 and g of negative 3 individually and then subtract those numbers. F of negative 3 would be negative 3 squared is positive 9, minus 3 times negative 3, so minus a negative or plus a positive 9, plus 2. 9 plus 9 is 18, plus 2 is 20. And then g of negative 3, well, 2 times negative 3 would be negative 6, minus 4 would be negative 10. Now we got to subtract f minus g, 20 minus negative 10, and that would be 30. If we want to get the formula in general for f minus g just of x, we take f of x minus g of x. And that simplifies to, we got x squared, we got minus 3x minus 2x, so minus 5x, and we got plus 2 minus a negative or plus a positive 4, so that's your plus 6. So if that's f minus g in general, then when we replace x with the specific number negative 3, we're looking at negative 3 squared minus 5 times negative 3 plus 6, which is 9 plus 15 plus 6, which does add up to 30. What's f times g of negative 3? Well, we already found that f of negative 3 is 20, and g of negative 3 is negative 10. So all we have to do is multiply those two numbers together, 20 times negative 10, and we get negative 200. So f times g of negative 3 is f of negative 3 times g of negative 3. But the general formula for f times g of any x, we can get that by multiplying together the formulas for f of x times g of x. So x squared minus 3x plus 2 times 2x minus 4. The x squared gets multiplied by the 2x and by the minus 4. The minus 3x gets multiplied by the 2x and the minus 4. And the plus 2 gets multiplied by the 2x and by the minus 4. And then after combining like terms, that's 2x cubed minus 10x squared plus 16x minus 8. Now if we take that and replace x with negative 3, so that we're evaluating f times g of negative 3, so that's 2 times negative 3 cubed minus 10 times negative 3 squared plus 16 times negative 3 minus 8. Negative 3 cubed would be negative 27. And negative 3 squared would be positive 9. So we've got 2 times negative 27, which is negative 54, minus 10 times 9, which is minus 90, plus 16 times minus 3, so minus 48. And then, oops, that should say, how'd that turn into a plus? Well, it should be a minus 8. That should be a minus 8. And then altogether, that comes out to be minus 200. So let's do a division example. What is f over g of negative 4? F divided by g. So f of negative 4, negative 4 squared is 16, minus 3 times 4 is minus a negative or plus a positive 12, plus 2 equals 30. G of negative 4, 2 times negative 4 is negative 8, minus 4 is negative 12. So then when we take f over g, that's 30 over negative 12. A positive divided by a negative comes out negative, and if we reduce that to lowest terms by dividing the numerator and denominator both by 6, it's negative 5/2. Or you can express it as a decimal. If you asked your calculator, what's 30 divided by negative 12, it would tell you that it's negative 2.5. Now, the formula for f over g, just in general, f over g of x, looks like this. X squared minus 3x plus 2 over 2x minus 4. So if we took that and put negative 4 in for x, we'd have negative 4 squared minus 3 times negative 4 plus 2 on top over 2 times negative 4 minus 4 on the bottom. And that would be 30 over negative 12, which would be negative 5/2 or negative 2.5. So in this video, we've looked at taking two functions and getting a new function from them by adding, subtracting, multiplying, or dividing. But there's another important way that we can combine two functions together to get a new function, and that is function composition. We can form the composite of the two functions, compose one with the other. And that will be the subject of the next video.